Hey folks, Matthew Lanigan here with Baywa RE. We're just going to give it another minute or two, still see people signing in, and we'll be back with you in just a moment. Hey folks, Matthew Lanigan here again with Baywa RE. I'm the Chief Commercial Officer here at Baywa. Really appreciate y'all taking a little bit of time to be with us and S5 and learn a little more about their product. Just a couple of housekeeping notes before we get going. This webinar will be recorded, so it will be put up on our YouTube channel. It will also go out in the monthly newsletter. If you haven't joined our YouTube channel, I would encourage you to go on there. You can see all of our previous webinars on there. You will be able to ask questions. Please put them down into the chat box in the bottom right corner. We will do our best to answer those in real time. Continuing education is a really big thing for Baywa. We like to do it internally, and we like to extend it to our customer base as well. So really appreciate you once again taking the time to be with us today. So without further ado, I would like to introduce S5. We have Mark, Director of Business Development, Brandon, Canadian Business Development Manager, Jesse, Application Engineer, and special guest Dustin Haddock with us as well. Without further ado, we'll pass it over to Mark.
All right, thank you, Matt. Let me turn on my screen, turn on my presentation. Is that all good?
Looks good. I'll start out. My name's Brandon, Business Development Manager for the Canadian market. Thank you again all for attending this. We like to do more of these educational presentations with Baywa and some of our other partners. And I just want to go around quickly and do a quick introduction. Today we have with us Mark Geis, who is our Director of Business Development over our solar division as well. Many years in the solar industry, so he has a lot of valuable input on this topic. We also have Jesse Winternitz, our Application Engineer, very helpful. We've got a solar calculator on our website for direct attach applications, but he can help in many ways with planning a project and can answer any questions engineer related to any of the projects that you have dealing with solar. And then we also have Dustin Haddock joining us today. He is our VP of R&D. Again, a lot of knowledge brought to this presentation. If we do, as you know, tons of testing, and Dustin is behind all of that. So he will be jumping in at different points when needed. And if you have any questions for any of us, feel free again during the presentation, like Matthew said, to put it in the chat, and we'll address that as we go. But let me turn it over. Dustin or Jesse, do you want to mention anything before Mark gets started?
No,
Just
just happy everybody's here. Thanks for the time, and yeah, I'm more or less here just to kind of ad hoc as necessary, or if there's any questions or anything like that that I can jump on, I'm happy to do it.
Thanks,
Yeah,
Dustin.
Sam, thanks for being here, everyone. I'm here to help out as needed and looking forward to working with most of you or hopefully all of you in the future.
Thanks, guys. All right, I'll turn it over to Mark.
all right. Thanks for joining us, everybody. Hope it's a good crowd out there. So I'm going to just leave this up here for a few seconds. You can just read it as you wish. So today we're going to really talk in pretty broad strokes about solar on metal roofs. You know, the advantages of it, what types there are, and getting into some of the technical aspects of it. I have a bunch of presentations that I start with this slide. This is in Colorado, just a gorgeous house with, I love to see solar on houses like this. Another aspect of this is that on the bottom edge, you can see snow retention. So it's common in snow country to put snow retention below solar on a metal roof, especially if you have doors, doorways, or places where people can get hurt or cars can get hurt. So it's not uncommon to see solar system with snow retention underneath it, and we actually are in that business as well. We sell snow retention. Okay. Another thing I'd like to mention is a lot of stuff we'll talk about is in a few papers that has been recently published by the Metal Construction Association. That's metalconstruction.org. Dustin and I were involved in these, so it's a really good series of papers, comprehensive papers on the ins and outs of putting solar and metal roofs. So I think they're good reads, and they're free to download from the MCA website.
If you're not familiar with MCA, I mean, they're kind of the authority as it relates to metal roofing. It encompasses every major metal roofing manufacturer in the United States, as well as, I don't know, you can kind of think of it like the SIA for the metal industry.
Thanks, Dustin. So one big aspect of why metal roofing is the best platform for solar is that they last forever. Oops, hold on. They've been around forever, and the roofs last forever. Here's a bunch of very special buildings around the world that we all know of. Those all have metal buildings, metal roofs, still intact today, except of course Notre Dame is no longer, has been burnt a few years ago. So the key is this durability, service life. Metal roofs, it's common to have metal roofs lasting 60 to 70 years. This specifically one with a good coating, a Galvalume coating. So that life cycle of a metal roof far outweigh is longer than a solar system service life. So to have an asset that has a 70-year lifespan, and you want to put a 30, 35, 40-year service life asset on top of that, there's no doubt that it's good to do it on a metal roof because of that aspect. Other roof types don't even come close to that longevity. As we show pictures of, there's a lot of buildings out there that have been around forever. So this is a chart that just shows that illustrates that impact, that issue of the coated steel is on the bottom, 60 plus years. And now if you look at 35 years, you want to keep a solar system on the roof, and you look at some of these other roof types, there's a discrepancy. And a lot of, just something that isn't talked about a lot, but so the likelihood of having to replace that roof in the midstream of the life cycle of a solar asset, there is a likelihood of that with some of these roof types, but not with metal roofs. Another aspect is in line with why we all are here doing solar. It's for sustainability, for environmental reasons, and metals is the most recyclable material there is, and combining that with the durability, the life cycle means you will not see a metal roof in a landfill, and you can't say that about asphalt roofs or rubber roofs. And then economically, So if you really look at this, and that we stress you to do this, is look at the roof plus solar as a single asset and look at it in the life cycle cost. Yes, it costs more to put a standing seam metal roof on a building, but it costs less to put the solar on it. And that's mainly due, and maybe Dustin can talk more about it, but it's due to there's just less racking usually. With other types of roofs, you're flashing and you're taking the time to flash. With a metal roof, you really don't do that. With standing seam roof, it's really easy to attach to the roof, so there's just less time involved. So all in all, you know, the combination of the cost of the roof plus putting the solar on, you're edged out a little bit with a metal roof, or at best even. But now if you factor in the likelihood of having to replace that roof at some point, that just blows it out of the water, because you just don't need to do that with a metal roof. So another way to illustrate this is a common way to analyze the financially analyze a solar system using cash flow analysis. So the blue line on the left is your initial cost. The black line above that horizontal black line is your yearly benefit from saving money from buying electricity, and that orange line is your accumulated cash. So those are the metrics. This is a real project. This is actually a system we put on our own manufacturing building, a 200 kilowatt system on our manufacturing building in Texas. And this is with including the ITC and the MACRs from the federal benefit, federal incentives. So you get a 20% IRR. Great, looks great. There's your cash. But then with other types of roof, the likelihood of having to replace that roof gives you a hit in the middle of that life of the system. And so now what that does is that just temporarily wipes out your cash flow, and you have to really restart it. So then so that area in the white is really your lost cash opportunity from having to do what you do, having to replace that. And the likelihood of that is greater with those type of roofs than it is with a metal roof. So if you really look at this again as the total single asset, roof plus solar plus life cycle costs, you can see the benefit of putting solar on a metal roof. All right, so I'm going to turn it over to Brandon now, if you want to switch to him. Everybody still there?
Yep, I'm here. Let me just, open this up here.
Okay.
All right. Do we have any questions this far on anything that Mark's covered so far before I continue to this?
Nothing in the queue yet.
Just need to get rid of this somehow. There we go. All right. So now we're going to talk a little bit about the main two categories of metal roofing. So we have here, this is the first one that we've already mentioned, standing seam metal roofing, which consists of a hidden clip on this system so that there is no, again, penetration in a roof system like this. And you can see in this diagram, there are two different styles of standing seam. So we have the mechanically seamed on the left, and then we have a snap lock, or also sometimes known as a nail strip profile on the right there. You can see in both pictures, you have a concealed clip that attaches to the purlin or substrate, and the panel then overlaps the clip. So again, there's no compromise to the panel itself. So let's start with mechanical seamed. This is laying panels over top of each other and actually using hand tools and a mechanical seamer to finish the profile, actually folding it over. Let's take a quick look at this. So you can see the male side of the panel with the concealed clip, and then the top piece, and then it's mechanically folded over with the seamer. You'll see that on a lot of the standing seam profiles on industrial and commercial buildings. This here, we have snap lock. There's a variety of different types of snap lock. You can see various profiles here. Some of them are considered in an architectural application as a nail strip, where the nail is put into the substrate, and then the overlapping panel clips on to the underlaying panel, and again creates a seamless, in a way, profile at the end of the application. We also have an applied lock, sort of a modern version of a batten lock system, where there's actually a cap, again concealed clip with two panels aligned together, and then a cap that snaps on over top of that. And that's quite popular in residential applications as well. Here is a breakdown of the different types of clips that exist. There are two main styles. This one is a dual component, or sometimes referred to as a floating clip. This means that the top section of the clip actually is able to move back and forth to compensate for some of the thermal expansion on a metal roof. And you'll see this used probably more often than a fixed clip. These are the single component or fixed clip. Again, it goes directly into your substrate or purlin, and does not move back and forth with thermal expansion. But in some cases it's necessary, in some cases it is not as important. You can see here in the picture on the left-hand side, when you have with standing seam roofs, when you have a concealed clip, you can actually see it a lot of times in the roof itself, and you can see here the arrows pointing to, and sometimes it's referred to in the industry as bleed through. So you actually see the placement of the clip, which can be a good thing when attaching clamps, and just knowing where your purlins or your attachment points are.
Let me jump in right quick. One of the reasons we like to point out finding the clip and knowing what kind of clip that you're using or that is being used on that roof is due to clamp placement. When you have a dual component clip like you see in the middle there, you can put a clamp anywhere on that roof, directly over a clip or not over a clip, and you're not gonna jeopardize the thermal integrity of the roof. When you get into those single component clips, you really want to avoid the clip locations, because when that roof is trying to move, that roof is moving frictionally along that single component clip. If you put a clamp directly over it, what's going to happen is you're going to inadvertently pin that panel. And so it's best when that style clip is being utilized to stay back from the clip at least 2 inches.
That's great. Thanks, Dustin. That's a really good point. Yeah, because you don't want to be placing a clamp over top of a fixed clip. You can see here is a variety, sort of a basic breakdown of the different profiles of standing seam. You can see here at the top left, we've got more architectural style panels that would attach to a flat substrate. Number 3, we've got a snap lock bulb seam on number 4. Trapezoidal rib, you'll see this in a lot of, it's a more structurally sound. This will be going over top of panels on a lot of industrial style jobs. We have a T, or again, sort of referred to sometimes as a batten style, not traditional board and batten, but it has a separate cap that goes over the 2 panels and is mechanically seamed over that. Number 7 is what we mentioned before, with a similar design as a snap lock. It just is a nail strip, so the nail is actually attached the lower panel is attached to the substrate with the nail, and then the overlaying panel snaps onto that. And then I had mentioned before, number 8, the applied cap system. So it is similar to a 6, where it's considered a batten style, but it's a snap cap that goes onto that profile. But as you will see in our next slide here, we have designed a specific clamp for each of these profile types that are out there, and we are able to help with the selection of that clamp to make sure, and we have on our website different resources that will help you figure out which type of clamp fits with the profile that you are seeing on the job site.
And Brandon, would you say that nail strip on a residential, isn't that becoming more and more popular?
It is. The nail strip, well, the nail strip and the snap lock tend to be a little more economically feasible at a lower cost. A lot of residential roofs take that into consideration. So you're seeing a lot of snap lock, plus the install time and labor cost is lowered as well, without having to use a mechanical seamer or have somebody who knows how to mechanically seam standing seam. Okay, we have a variety you can see here, depending on the profile, whether it's a double lock, which is on the left-hand side here with the V, that's a 1-inch double lock. And then you have your H90 for your 90-degree seam or single fold. And then you have your H, some profiles are more open, as you can see on the right-hand side there. Okay, I'm gonna jump into our connections, what we actually, the different type of fastener that we use to attach the clamp to the panel to create a mechanical lock. So you can see that a lot of times, with certain manufacturers, they're looking to use a cut point screw. What that does is actually digs into the material, can compromise the warranty of the roof and the paint on that, where we at S5 use a round point screw and a round point fastener, and that way it actually creates a dimple that will then create the mechanical bond where it fits inside. So you can see here from the diagram that it doesn't cut into the material. It simply, you can see on the top right-hand side, creates a dimple, a mechanical lock. So there's no friction bond where it's not going to be sliding. It actually creates that dimple and creates that lock, which will increase the holding strength of the clamp itself.
Hey, Brandon, really quick here, if you don't mind, I'm just going to jump in to elaborate a tiny bit. So this is a really important aspect of what makes our clamps different and some of the history we have with some of these metal roof manufacturers. Our round point set screws are a little bit more expensive, but they're so important to use because they don't corrode or scratch away any of the coating, the galvalume on the metal roof. And by doing that, we protect the integrity of the roof, but it allows for that mechanical interlock, which is very important for certain jobs in certain jurisdictions. LA County, Miami-Dade, they really look for that. The cut point set screws, a little bit more common. Some of our competitors go towards those. The issue with that is that it tears away the coating, and we've seen this in the field over years and years of reviewing projects, where it actually creates a premature corrosion. And if you talk to the standing seam manufacturers themselves, they'll tell you definitely do everything possible to avoid that. It will quite drastically affect the lifespan of a metal roof.
That's great, thank you, Jesse. And you can see a closer picture of it here. It creates the dimple on the one side, a little bit of a protrusion on the back side, and again, you can see from the diagram that's there that it creates a pocket that the set screw sits in that allows it to remain seated and not slide down the seam of the panel. We're going to jump into the other style panel. So we did talk about standing seam there. You'll also notice a lot of agricultural applications, again, a less expensive option. You have trapezoidal rib panels, quite popular in a lot of different markets around the world. And we have an assortment of clamps. This is also known, these are also known as an exposed fastened or through fastened, screw fastened roof. So that means that you're actually putting fasteners through the skin of the panel into the substrate below. Again, you'll see these, they're quite common. Again, less expensive, a little bit longer to install with having to put all the fasteners in, but this is a big part of the metal roofing market is exposed fasten. So you'll see here, there's no need to have the clamping system that we have for a standing seam because there aren't seams in the same way to attach our clamps to. So that's why we look at products like our brackets here, which have screws that penetrate the skin of the panel. Right here, you guys are probably familiar with this solar foot. This would be attached to a panel for solar application. If you're adding an L bracket to that and placing your panel or rail off of that system. Again, hardware is not included. Again, it must attach to the structure or the substrate below the panel. It can't just be on the skin itself. We have rib brackets, which will go over top of the rib itself. We have various profiles of these brackets in order to fit the different geometry of the trapezoid on various panels that are in the market. Again, you can see there's space in that in terms of a solar application to put an attachment system on top of this bracket so that solar panels can be attached to your roof here. And we're going to talk about, Mark's going to jump in a minute or so and talk about the fastener technology we have that we use with this. This is a Protea bracket that we carry. I think you guys are familiar with this as well. Sort of more of a one size fits all for the most part. Comes with the L foot included in the part itself. A little more costly than a rib bracket, but a lot more flexible in terms of its application. You can see here our Protea bracket being used with our direct attach PV kit system, which we'll touch on lightly in a few minutes. So we have a different, with the Protea bracket, there are 3 apex options. So you can do a side rail mount, top rail mount, and also, again, our PV kit, which is a direct attach system for solar install. We also have Versa Guard. This is a bracket that also can be used for rail mount systems with solar applications, and it is also an option when it comes to the brackets that we provide. You can see here in the picture on the left-hand side, they've got rail attached to the Versa Guard bracket.
And on the right is it's actually used for our snow retention product line as well.
Yeah, we use it for a 2-bar snow retention system. So yes, thanks, Mark. Next, we have a corrugated panel. Again, you'll see this is quite familiar. A lot of agricultural applications use this. It's corrugated like the inside of a cardboard panel. You'll see this sort of profile, and I'm sure you guys are familiar with it. We have specific products that fit the corrugated profile, one being the core bracket, which attaches in the valleys. And again, Mark's going to talk about the fastener technology that goes with this, and you can see that there is butyl installed on this product to eliminate any water penetration in this instance. We also have a system, and again, this is primarily used, this is 100% used for solar applications. It's actually attaching to the ridge of the corrugated panel, and it has room in the bracket for wire management, attaching other products, whether it's L-foot or PV kit or an attachment to rail. So we have two options when it comes to this.
Brandon, real quick on this, this is designed, you know, like Brandon said, primarily for solar applications. The little V that you see there also helps if you do go into structure. So let's say you can find structure and you want to go into structure with this part, you can do that and not over compress the corrugation. That V kind of helps as a stopper, as well as when you're just walking around, keeping from crushing those corrugations.
Thanks, Dustin. Okay, I'm going to turn it back to Mark. Emma, if we can switch it back to Mark. And
We do have a question here, guys. I'm just pulling it up. A few seconds. Let me blow this up. Is there a torque spec for the trapezoidal application or any of the penetration application? And have customers dealt with stripping out holes? And for standing seam, is there a recommended tool for attached? Can an impact drill be used, or a torque wrench, or a combo with spot checking with torque wrench impact?
Oh, perfect. Thank you. I'll jump on that one really quickly here. The first question, when it comes to our exposed fasten product lines, specifically the sheeting only ones, the rib bracket line and the core bracket line, that's best done actually with a visual check. There's an EPDM washer on the bottom of those fasteners. So as you're screwing it in, you'll start to see that washer compress and expand out a little bit. And that's your indication to stop tightening it down. Don't over tighten it any further, because if you do continue, especially if you're on a drill setting, you do run into a risk of stripping out the roof, at which point you'd have to fall back to some sort of popper of it. And obviously we want to avoid that if possible. When it comes to the standing seam clamps, the best option is to use some sort of gun that has a torque setting that you can program. That way you can, torque down, fasten down until you reach that setting and the gun will stop. We do recommend you also use a torque wrench though, and do check, periodically to make sure that the set screws are reaching the appropriate torque, as torquing the set screws down is such an important aspect of an installation. I see Dustin just jumped on here though, so I'm going to let him pick up where I left off.
Yeah, one of the things I just kind of wanted to reiterate is, like what Jesse was saying, is you've got screw guns. There's screw guns out there, impact guns that are, adjustable. You've got a clutch or something like that that's adjustable, where you can set the torque on a clamp, check the torque with your torque wrench, and then see what your gun's delivering, so that you can kind of judge it that way and not have to inspect every single clamp. You just do it periodically. Coming back to the needle point in the sheet only, again, like what Jesse said, if you do strip it out, you do want to, remove that fastener and put in either like a bolt type rivet. And when it comes to trying to figure out what is the right torque, we tried and tried and tried. We can tell you what it's going to strip at in terms of torque values on various metals, but really the visual is a much better method than trying to figure out what the torque wrench, and part of that has to do with the consistency of the metal, and the tensile strength of the metal is going to vary throughout the sheet. And if you've ever run a bunch of screws into sheet, you'll see sometimes that you might have the choke set way down on your gun, and it screws in just fine on one screw, and then the next screw you can't even get it to go more than 50% secured. So let's just give you an idea there.
Hey Dustin, what is preferred, an impact gun or a screw gun, or does it matter?
I mean, the way that impact guns have gone in terms of technology, they're leaps and bounds ahead of where they were 5 even 5 years ago. When I'm installing, I prefer an impact when I'm doing clamps for sure. But when it comes to sheet screws, I use a screw gun as opposed to an impact, because the impact, I mean, you can do it, but you do run the risk of, I mean, that's delivering a lot more torque. So
Cool. All right. So, so within the installer community, there's, you know, not everybody, definitely some people embrace and welcome installing solar on trapezoidal roofs or corrugated roofs, exposed fastened roofs, but there are quite a few installers who hesitate and really won't quote that. And, you know, they just don't like the concept of introducing more holes into an exposed fastened roof. But I'll explain the technology that is really the technology that's used to build the roof itself. And if it's done properly, there should be no fear of you know, of leaking. So don't hesitate to do these roofs. Oops, okay. So that one technology that's out there would be a drilling screws. That's the wrong screw to use. What that does is it just removes material. It creates just a single hole, and that's just a very tiny bit of a thread, basically. So not a lot of pull-out strength. As well, it drops. You see in the bottom, it drops little pieces of metal, swarf. We call it, and that will eventually begin rusting the roof prematurely. So
actually, what happens with the swarf is, if you're familiar with the coating on that roof, it's a galvalume coating, which is a zinc aluminum coating. And aluminum will oxide really, really quickly. And what ends up happening with your swarf is you'll get the cut edge is gonna rust rather quickly. And then the aluminum oxide on that roof is gonna lock that mark, that stain in that roof like forever. And so it's not necessarily prematurely corroding the roof, but
Okay.
it is locking in a nasty stain that's going to be there forever, because that oxide layer just locks it in.
Sounds good.
But swarf will also cause with scratches, more than just a rust-like appearance. You can walk on it and stuff like that and get scratches all over the roof.
So still not a good thing, basically.
Right.
So the technology that we prefer is what's called a self-piercing screw. And our screw that we use, we designed ourselves. It's not patented, but we designed it. It's a steel, full-bodied steel screw, hardened steel to be able to penetrate. And what it does is it creates a little tunnel. So it pierces it, creates a little tunnel, and that creates extra thread. And then on the top, we actually have a stainless steel cap that's pressed over the steel part. So it's whatever can be exposed to the elements is a stainless steel cap, and inside is a hardened steel coated thread. And there is a washer in there as well. So what that does is it creates more pull-out strength because you have more thread. You don't have the swarf. It's a better assembly technology. This is when you're just screwing into the sheet itself, not into structure.
Yeah, and another point that is critical is when you're using a drilling fastener. If you've ever used a drilling fastener, if you're screwing straight down at a 90-degree, like on the top of that rib, you know, a drilling fastener is fairly easy to deal with. But when you're coming into an angled wall, like the side of a trapezoid, you know, that driller is going to try to walk all over the place, and you'll fall off. You'll fall off that fastener probably 3 or 4 times before you get it set. With this piercing, it's like going into butter. It's a much better screw for this application.
And then again, then on the sealant side, the second part of the technology, anything that is out of that drainage plane, anything that area that could flood, like this, we use EPDM, and that's adequate. And I'll show you the testing we do. But this area really can't be submerged, very unlikely to be submerged, but it does actually, you can get wet for sure from wind-driven rain, and you know, it needs a good seal, but EPDM is good enough. Here's a picture of our Protea bracket and the EPDM sealant. And please take off the piece of paper before you put it on. So then all our products that are on that drainage plane, the ones that screw into structure, all have a butyl seal, and that is the best sealant material for roofs. That's what actually these roofs are used between roof panels. Butyl is used to seal those. So there's a picture of the underside of our solar foot. You can see the butyl seal. It never gets hard. It is the best sealant. It's more expensive than EPDM for sure, but that's really what's needed for this to screw into structure, because that area can be flooded and can get submerged. So that's important. So here's actually a picture of butyl seal in a roof panel. So actually, Dustin's dad, the founder of our company, he was involved. He's also a forensics expert who's called upon for various projects, and he did a large project where they went around the country, opened up some roofs of various ages, and analyzed that butyl seal. And the conclusion was the butyl seal really had the same, was very similar to what would have been if it was brand new. So had not decayed or compromised its sealing ability after 33 years. So it really lasts the life of the roof itself. And that's exactly the same sealant that we use for those type of brackets that go on the drainage plan. So what we do for testing, and not everybody does this, we do a E214-2140 test, which is a submersion test. So it's an ASTM test, 6 inches of water, I think 6 hours, and if a single drop of water goes through, it fails. And all of our brackets have, we recently did, these are from recent testing, we just did another round of testing of this, and they all our products passed.
Yeah, that's 6 inches of static water pressure. And to give you some idea why this is such a robust test is the amount of weight of 6 inches of water pressure, being applied to those penetrations. It's not an easy test to pass. And most of what you'll see out there is like if it's a asphalt shingle flashing or some other kind of product, is the industry kind of has adopted, a wind-driven rain test, which is not as robust of a test. We utilize this test method because it's a more severe test method, as well as it's what is respected in the metal roofing industry as for testing the joints in like a standing seam or something like that. So we make products that are intended for the roof. We test them in the way in which the roof is tested.
Thanks, Dustin. All right, so now let's get into exactly how various ways of mounting solar on metal roofs. These are two great examples. The one on the left is Apple's headquarters, 7.4 megawatts, and that is actually a standing seam roof on a donut building. So the seams are actually not parallel to each other. They're tighter together at the bottom than they are on the outer rim. Those modules are in portrait. Dustin can talk more about it, but that was a really complicated project for us, and it is our direct attached PV kit. And there's not a single penetration on that roof, including walkways, coping, and all wire management, all home runs. And the one on the right is a typical residential roof. We showed you a picture earlier one. I mean, that's, we all know what this looks like, but it's a typical metal roof residence with solar on it. Both ends of the spectrum, 2 kilowatts versus 740 megawatts, 7.4 megawatts, sorry. So probably the more common type is a flush rail system. So you can see in the circle the rails, the modules are flat, flush to the roof. There's a gap in between, a height off the roof, generally 5, 6, 7 inches or more, and there's maybe a 1/4 inch gap between the modules. The pros are that it gives you full density, it gives you as much power you can get out of a roof. The cons are that when O&M comes around, it's more difficult to do that. You guys all face these issues of how to decide where to put O&M aisles and spacing, but this is a very typical mounting way to mount solar on metal roofs. This is a residential steep slope. The red dots are where the rail is underneath. The modules go perpendicular to the rails, which are perpendicular to the seams, so that you end up with a portrait orientation generally. Now, the second type is a flush as well, but it's a direct attach. Our PV kit is one of them. There are other ones out there. And you can see that in the circle in the red, the reason I circled that is that the seams coming out are very similar to that last picture of the rails. So in this scenario, their seams act as rails basically. And our message is that you don't need to put rails over rails. So, but this is another type, flush direct. The third type is a tilt mounted system. This was common years ago, more common years ago. It's been trending away from that towards more flush mount. It's because the prices of modules have gone down. So each module with a tilt gets more energy per year out of every module if it's tilted closer to the sun angle, but you can't put as much because you do need shade spacing for, inner row spacing to prevent shading. It's actually more expensive. As you can see, there's just more hardware you're looking at to do that. And so the trend has been towards flush systems because people will just want to put more modules, even though that each module is producing less energy. From our perspective, that's what we see. But at S5, we're mainly about the clamp, the connection to the roof. So we support rail-based systems, railless systems, tilted systems. And then another type that you see getting more and more popular are short rails or micro rails. So the idea is, instead of one long rail, you just have short pieces of rail where you need them. So it's less material, easier to handle. There's a little bit more work, I think, because instead of lining up one rail across, you're lining up multiple rails before you put your clamps on to put the module down. This is Aero Compact's product. But again, we support this product with clamps. So I'm going to just talk briefly about a railless PV system. Here's that same picture showing the our PV kit, which is railless. I'm going to not get into much detail. I'd like anybody who wants to talk more about this, just get in contact with us. Here's just another picture of it. The circles in the back, those are mid clamps. The ones you see in the forefront, those are edge grabs, edge conditions. Just another view of that. One aspect of it is, with less rails, there's really less mounting material up there. This is a case where you needed 3 clamps per side because it's a high roof height or high wind situation where you needed the strength. And so in this case, you just add more PV kits. Basically, if you had a rail-based system, you'd have to add a 3rd rail on every row. Again, the mother of all projects for us, this is Apple. This is a standing seam roof with our PV kit. I'm just going to go briefly through this. Since there are no rails, one pushback from residential is where do people step and how do you really to assemble these products. I'm going to show you the benefits. So these are right there. So you snap one line and you put your row of clamps where needed, and then that's all the measuring you need to do. From there, put scaffolding up, and from there on, all the clamps go on the fly. So there's no more measuring. You're not laying more rail and measuring and snapping lines. It's all on the fly. So the module is the jig. So you're just saving time by not having to lay that ahead of time. And it's best to build up a column because you have that scaffolding because you're not stepping on rails. So you need scaffolding and fall protection. But it's simple. And then you just keep going. Okay. And that's it. Here's a project comparison from our analysis that overall for the racking part only and in installation, you could save in total, we save about 38% or more of your installation costs for the racking. And it's about 85% less weight of racking. A picture's worth 1,000 words. This is 250 kilowatts of rail about to go across the country to a site. I was there. And then this is 250 kilowatts of a direct attach. So now I'm going to get into a little bit of the technical aspect, and going back to a rail-based system. It's common to buy rail, like say from Iron Ridge or Unirac or another company, and then you want to use S5 clamps. So that interplay of when you're going to permitting and figuring out how many clamps do I need? Is it strong enough? I'm just going to kind of go through that because I think it's interesting to know that. So this is really a wind map. I'm just throwing this in there. This is from ASE 716, a wind map. So this is one of the factors. This is US, sorry, not Canada. This is one of the parameters that gets plugged in to figure out what the pressure is going to be on a roof and so how strong it needs to be. And this is in ASCE 7, that QZ, that's peak velocity pressure. So those are all the factors, your wind speed, the building height, a bunch of parameters are used to input, and structural engineers do these calculations to develop like how much pressure is going to be on that roof, how strong does that need to be. And then from say Iron Ridge or whoever you'd buy the rail from, you end up you can get span charts, and you see these are part of your permit package. And the circle on the right, those say these are the reaction forces. So so in zone 1 of the roof, you need 132 pounds of resistance to qualify, to meet, to be in compliance. In zone 2, you need 267. And in zone 3, which is the corner zone of a roof, you need 208. PS, which sounds interesting. Oh, you know what? I think that in zone 3 you have less spacing. There's 24-inch spacing on that, so you only have 200 pounds. So what do you do with that? Now, what we do, and this is something that we're really proud of, is we do a ton of testing to give you that next piece of information, because you'll get those span charts and it'll say, what are my reaction forces? How strong I need these clamps to be on the roof? And we provide that information. We do a ton of testing across all our clamps and brackets and various types of the roof thicknesses and the roof types that can be tested. I mean, something that we do that nobody else does. For instance, this one, the ultimate is written on there 2,000 pounds. If you use a factor of safety 3, you're talking 700 pounds for that, which exceeds what you needed from what I showed you before.
Yeah, another reason why it's important is you see that roof where, it's getting over 2,000 pounds of holding strength. Not all metal roofs are the same, and the performance of a clamp isn't going to be the same across the board, which is why we do all the tests. I mean, like that applied cap that we showed early on in this presentation, a roof like that's going to fail at 250 pounds. And that's kind of a critical factor as to why we test the way we test. And we might have 5 different test results on one roof profile because they run it in 5 different materials, because not only will the same profile test differently, but if it's made in aluminum, it's going to test different than if it's made in stainless steel or if it's made in galvanum.
Yeah, definitely. So here's an illustration of that. This is the normal to seam. So this is pulling up. So, this is something we're proud of. We do thousands of these tests, and it's important, whoever you get this, whoever you work with, they have this testing done by a third party, an accredited lab. That's very important, and that's what we do. Also, we test parallel to the seam, because in snow, in a steep slope roof with snow or seismic conditions, you do get forces that are lateral, that are parallel to that seam. So we test in that direction as well. You can see the test setup. You can see how we do that. That's important for us. Not everybody does that. So the results are, we have a load tables that are in our website that you can just find the combination of clamp and the material and as you can see, the different gauges and what those ultimate loads and the allowable load based on a factor of safety you set. You can also get reports that you may need to put into your permit package. We provide all that, and Jesse for sure, can help you with that as far as figuring that out. But we have all that data for you to work. And again, it's, especially with rail-based systems, we need to match up to what the reaction forces are that the rail manufacturer dictates. That's how we work together. So other testing that we do, we were part of a study to demonstrate that, yes, putting solar on a metal roofs don't burn. So, and the testing for UL 2703, which is the standard for racking systems, the fire test didn't matter if your product was for a metal roof or any roof, you had to do the test on a rubber material like TPO. And so we proved, and we actually have an exception now in 2703, that if you have a system that has certain percentage of metal, or like, more than 90% or something, whatever that is, you can get a Class A rating as a system. Again, here's our flood test, the 2140, our submersion test. If a single drop of water comes out, it's a fail. All our products have passed. Showing that test. Oops, jeez. Here's another picture of the test on the left, the water test. On the right is just another pull test. I just wanted to show more pictures of that. Another aspect of testing is salt spray analysis. It's part of the standard. We've done a ton of that as well. And what's the important part of this is not about how much each individual part will corrode over time. It's really about the compatibility of the metal. And this is really important for metal roofs. And we demonstrate that we have aluminum and stainless steel on that roof after 2,000 hours of salt spray. Yes, that roof is corroding, but all the components are intact. The set screw is good. Everything's good. If there was some kind of galvanic reaction going on because you don't have a good choice of what materials to put next to each other, one of the materials would be chewed away from this test. 2,000 hours of salt spray. So if that aluminum was if that was a pure steel right up to the aluminum, this is coated steel, you might get some migration and you might get some damage from a galvanic reaction. But our products on coated roofs are fine. Here's just a reference list of the materials our products are compatible with. And for instance, copper roofs, we have a brass clamp for copper roofs, because putting aluminum on copper, it's not coated, can corrode, can create this galvanic reaction that I talked about. So I'm not going to go into all these items, but these are all, we've documented this as far as what materials are good, what works, what doesn't work. So all that information I was talking about, the do's and don'ts and more of that, as I said, we're all put into these 3 papers. And the last paper, actually, we said all this information, how do we compile it so people can use it?
Sorry, guys, we do have a quick question here.
Yep.
With the railless system, how do you accommodate the warranty clamping zones by the module manufacturer? If you have 24-inch OC seams, you cannot hit the clamping zones required.
So it's basically a geometry problem. So every modules are, there's various sizes of modules, various sizes of the loading zones, I call them. And that's basically out of the install manual. And then our product, and then if you match that up with roofs, yeah, there's differences. You have roofs that have seams 24 inches. Then they go small. There's 18-inch, 16-inch. Trapezoidal roofs are 12 inches or smaller. Corrugated is 2 3/4. So the tighter the spacing, the more apt you are to be able to hit these. But it presents a geometry problem that may sometimes need to be solved by having what we call a correction gap. So you may have a couple modules, and then you may have a gap to reset so that you do hit these. And we can help you with that. We do this all the time. We grab the install manuals, look at these. We sometimes even talk to the module manufacturers about it. But in some cases, and I have pictures of that in another presentation, in some cases, you may have 2 or 3 modules and then you may have a correction gap. So that's the way to solve it, is with a correction gap. Now, the benefit of that is you can really set up O&M aisles, which I talked about before. And I know there's a lot of pressure to put as much on the roof, but it is what it is. And, there are definitely benefits to having aisles that you can walk on, if that's how big the correction gap is, that you can perform O&M, and it actually helps the installation as well. And what you end up with, in a lot of cases, you can work around that. We have a lot of pictures of that with correction gaps that you maybe lose 1% or 2% of your usable solar zone. And there are some cases where it doesn't match up as well. And and honestly, you have a choice to make about whether to go with rails or whether to go with the direct attach.
And we also have a tool, or with our solar calculator, and Jesse
Right.
can talk more about that, but it will look at where the mounting zones are and how that correlates to your seam spacing. And then, like what Mark was saying, a lot of times we'll work directly with the module producer. So when we run a 2703 mechanical load test, we're going to bump those mounting zones as best we can, so that you have more usable space on the module itself when we run the mechanical load tests. And like with Apple, we had to cantilever that module 50% and mount on the short side. And so what we ended up doing with that is running a lot of specialized tests on the modules and the proposed mounting zones, to make that module work for that Apple project.
Okay, cool. Thanks, Dustin. So where I was jumping into is that sort of all this collective knowledge and that we put, and it's in this paper, is that when we touched on a lot of these, we created a checklist. And the checklist, the purpose of that is just an unofficial guide that you can use to reference to make sure like all these important things are hit upon. And it goes from, it's one page in this in that last paper, paper 3. I have it on 2 slides, but it's 1 page, and it starts out with just ensuring the engineering is done on the site, that you know what the requirements are, and you guys all know that to do that. And then it gets into specifically what are the best alloys to use. It gets into some specifics, what they have to be listed, certified and in compliance with. Then it gets into the gasketing and the proper way to do that, which we talked about. And then in the end, it talks about as well, look into the manufacturer to make sure that you have faith in them, that they're a reputable company, that they do the right things, ISO 9000 certified, and they make what they say they make, and they have the proper quality systems to ensure you're getting the right product. So it's a lot of different things that are really needed to make sure you have a great system, and we tried to compile that into a usable checklist. So I'm going to hope it's okay if we indulge a little bit. I'm going to talk a little bit about S5, why I'm proud to be there, and why I think we're a great company in this space, and our brand is well known with metal roof attachments. Founded by Rob Haddock in 1992, he'd been a metal roofer for 20 years and he basically, the standing seam clamp, a few companies make it now, but he invented it. So in 1990 or something, he patented that. He invented that, including starting out with wood, making out of wood first. He himself is a sought after expert, metal roofing expert. He teaches in University of Wisconsin. That science, he's sought after to do experiments and to be a witness. And then he sort of took that product and created S5 and built S5 around that. Things that we are proud of is, as I said, we're metal roofers who got into solar, and I think that's a good story. We have now 4.6 gigawatts of installed product out there with our product one way or another. Our product is on 4.6 gigawatts of solar. As I said, that I'm proud of, as we've done thousands of tests on all kinds of combinations, and using an independent third-party lab. We actually have a lifetime warranty now on our products. I should update this. We straddle the solar industry and the metal roofing industry, and we spend a lot of time in both communities, on committees, helping evolve the industry. We have a relationship with all the stakeholders, and as it says there, we manufacture in Texas, and it's a ISO 9001 certified manufacturing plant. As well, on the roofing side, we have the same approach. We're involved in industry groups. We lead those. We're heavily involved in evolving the industry. We spend time with all the major roofing companies, getting their endorsements and approvals and their feedback to help us evolve our product line. Here is our manufacturing plant in Texas. I've been there a few times, and I know manufacturing, it's a really nice place to be in. It's a well-run place. And if it looks like a Walmart, it's because it was a Walmart. outside of Wichita Falls, Texas, that we bought and created a manufacturing plant. Now we've more than doubled the size of it since then.
I just wanted to mention quickly too, on the list of manufacturers we deal with, that was a lot of them in the US and a few internationally, but we are connected with a lot of the major panel manufacturers in Canada as well. A lot of what you're going to be seeing on your roofs out in the field.
Yep. So that's all I've got. Dustin, you want to add anything, or anybody?
I just want to be conscious of everybody's time. See if we have any more questions.
Don't see any at the moment. So folks, if you have any questions, please get them in here right away.
And thank you all for attending.
Thank
And
you.
again, if there's anything you guys think of after the presentation, feel free. Our contact information is there. Reach out to any one of us, and we can help you at that point.
How do you tighten below solar modules?
Tighten
think-
the solar modules.
The valley screws.
I mean, those are. So is this with a rail based or with a direct attach?
From rib panels, sorry.
I mean, if we're talking about the PV kit and using the PV kit on an exposed facet metal roof, what we end up using is a bit extender, where you're not really having to get all the way underneath the module. You're coming in at a slight angle in some cases, but the bit extender on your gun is definitely going to help with that.
Yep.
And he clarifies, I mean normal maintenance trap rib. Okay, and then he says, okay. Okay, we can round back with John on that as well. It is, the time has come to an end here. So I do want to thank everybody for taking the time to be with us here today. Really appreciate it. Thank you, S5. Really appreciate taking the time to be with us and our customers. Once again, this was recorded. We will share this on our YouTube channel, and it will go out in your monthly newsletters. If you do have follow-up questions, please reach out to our reps. The one thing I've learned with S5 over the years is the first thing you do when you have a question, you're trying to figure it out, just call us or call them. The customer service is fantastic when you're trying to establish which clamp you need for the roofing type. Super quick responses. So really, we just need to know the roofing type, the gauge, and if you have a photo of the roof with a measuring tape on it, that helps a lot. But it's super quick turnaround on that. And, everybody makes sure they reduce their risks and get the proper products on the roof to begin with. But once again, thank you so much. Thank you, S5, and everybody have a great day.
Thank you, Matthew, Baywa, for having us. We really appreciate working with you guys.
Sure.